Hi, hello. My name is Kuba. I'm working as a software engineer in security team at Yelp. And I'm here to tell you today about how we automated our malware response at Yelp. So first, a couple of words about me. I started at Yelp around 2 years ago. And since then, I've been mostly involved in our malware incident response process. And also, in the meantime, automating and basically working on our security processes. Before that, I used to work at SAP in Sophia Antipolis in France in a security and trust research group. And prior to that, I was studying in Krakow and also doing joint degree with the University of Telecom Paritech, Institute Eurocom, also in Sophia Antipolis. So just sort of a quick recap, Yelp's mission is to connect people with great local businesses. And this led over the past 12 years since the company started to over 102 million reviews, as you can see on this slide. 90 million of the users are coming from the mobile websites and applications. Around 70% of the searches are also from mobile and web apps, mobile apps and basically our mobile app website. And right now, Yelp is present in 32 countries worldwide. So what I'm trying to say by showing you all of these stats is basically that we have more than 4,000 employees by now. And most of them are actually using MacBooks to do their daily job. So sort of a quick introduction to our malware incident response process. This sort of starts when one of our employees gets an alert, either like some detection by our endpoint monitoring software or some network monitoring stuff. That detects some suspicious binaries on the user's machine or some suspicious network traffic coming from a particular machine. But just let me first introduce you sort of to people involved in all this process. So first we'll have a Yelp employee who typically uses MacBook to perform his daily duties. And from time to time, they will wander to some gray sites of the internet, right? For instance, get alert to download latest update to Adobe Flash Player or some free video converter app, which comes packaged with malware, also for free. We have help desk engineers, so they are kind of serving as an interface between users and us, the security team. Help desk engineers are the best people to perform all this task. They have best outreach to the users in terms of both different time zones and different locations, because Yelp is also present in various locations around the globe. Our offices are in various locations around the globe. And we have also a security team that is also consisting of malware analysts, so the people who are basically in charge of analyzing the alerts about malware infections on someone's machines. So job of malware analyst is typically to answer these three questions: how the malware got there in the first place, is the machine even infected or not, and how we can prevent and detect further infections to sort of stop spreading malware all over our company infrastructure. So there used to be lots of false positive in our approach in the alerts we were receiving. So we started involving malware analysts as early in the process as possible. So we are doing this initial triage. And this is basically to establish whether this is a real alert or a false positive, whether it's something like Windows threat on macOS machines that we don't really care about. And this is sort of to save us time from all these other tasks like forensics collection and forensics analysis. So if we can filter out sort of as quickly as possible whether this is a real threat or not, this is always saving us some time. But our traditional sort of approach involved later on, after this initial triage, basically collecting forensics from the machine. I'll tell about this a bit more in the next slides. This task used to be performed by our help desk ninjas. So they're like, as I mentioned, the best people to do it because they are really living close to the users. They can just go grab someone's machines, take it off the network, run the necessary collection scripts, get the output back, and then the malware analyst can start analyzing the output. So they can assess the risk related to the infection. So when it comes to different kind of tools we have available for digital forensics collection on macOS, there is OS X Editor. So this is script that's more or less inactive for the past few months. It's open source on GitHub. It lets you collect different properties from macOS machines. There is OS Query, which also is open source project, open source by Facebook. It allows you to query different system properties like you will be querying SQL database. Knock Knock is also quite a useful tool that lets you figure out which processes are running on your macOS machines. So this may give you more insights into whether there are some known processes like system processes or something that was actually installed by the user, potentially packaged with malware. There is Google Rapid Response Framework. This is a bit more intrusive. They let you, for instance, collect file samples. So it also gives you more insights in terms of whether the machine is infected with something or not, because they give you possibility to collect the samples of the files from the machines as well. I'd like to also mention a book that was recently released. It's OS X Incident Response Scripting Analysis by Jerome Bradley. This book also comes with kind of ideas for scripts that you can basically have to collect various forensics from macOS machines, and also gives you some ideas about how to analyze them. At Yelp, we use OS X Collector, which is a tool based on OS X Editor. It's also open source on GitHub. So this is a forensic evidence collection analysis toolkit for OS X. We open sourced it some 2 years ago. It was actually the first project I worked on when I joined Yelp, so I'm pretty proud of it that it's still up there and still used by people. Actually, let me get a quick show of hands. How many of you are familiar with OS X Collector in the audience? A couple of hands, okay. Cool, so basically what OS X Collector is a simple Python script that you run on potentially infected machine. It will collect various system properties. You see it here on this slide, and then output them as a JSON file so that analysts can take this file and try to figure out all these properties, whether machine is infected or not. So the way OS X Collector runs is it gathers all this different information from plist, which are kind of like, you would say, Windows registry things on macOS machines. Various SQLite databases that also macOS uses to store system properties, as well as some other local file system information for instance, for applications installed on the system or browser history, browser extension, things like that. So here is an example of how such a JSON entry collected by OS X Collector looks like. It comes with some common keys like file paths, file hashes, timestamps. There are also signature chains, for instance, for binaries that might be useful to figure out whether this is something we expect on the system or not. So what we used to do later on, after collecting all these files from the potentially infected machine, is that malware analysts would basically sit down and with some simple tools like grep or JQ, which is actually quite a cool thing for JSON visualization, they will go through the scripts basically trying to find some events that were happening around a certain time frame, or it will also allow you to, with help of JQ, filter and show only URLs related to users' activity around a certain time frame. And basically, based on that, analysts will try to figure out where, for instance, the file was downloaded from, or when the file was installed by the user, trying basically to figure out answers to these questions I mentioned earlier. So this also works pretty well, but if you have 30,000 lines of JSON output, it may come as a really job of basically looking at a lot of JSON. And don't get me wrong, like, I like JSON. JSON is very pretty, it is simple, but it's also very easy to read and process by code, from code. So actually, why don't we let code process the JSON output? And this is what we sort of done as the next step. So early on, we automated the JSON analysis process with what we called OS X Collector output filters. And they basically, what they do is they augment the initial JSON with all different properties, for instance, the information from our internal blacklists or information from some external threat intelligence APIs. they will also try to construct the list of related files to files that are potentially infected, and then produce some sort of summary of findings. So this is all really cool. It automates the whole kind of analysis process, but the tool itself, OSX collector output filters, it was quite tedious to maintain because malware analysts had to basically get the installation of the tool on their machine. When they started the analysis, they had to also basically sit there, watch it running. If the machine went to sleep, or if they decided to close the machine, or for whatever reason they lost internet connections, all this sort of process will kind of halt, and then they all have to restart it because it connects to various external threat intel APIs via HTTP. So basically, the tool was not written in a way that allowed them to kind of pause it and resume it at a certain point of time. Also, not to mention that basically whenever there was new version of this OSX collector output filters, malware analysts were in charge of themselves updating the source code, getting all of the dependencies. So it was really, really tedious task, and not something we were looking to do with the process that we were actually trying to automate. So we thought we can do better, and we turned the OSX collector output filters into a service. And we called this service Amira, Automated Malware Incident Response and Analysis. So right now with Amira, what analyst is doing is just dropping the OSX collector output file to the S3 bucket, and Amira will automatically trigger the analysis of the new object in the bucket. This is based on a thing called S3 event notifications. So we have configured this S3 bucket basically to send a notification to an SQSQ whenever there is new object in this bucket. This SQSQ is called here on the slide Amira S3 event notifications. So whenever there is a new object created, a notification will be sent to this queue. Amira will periodically check for the new messages in the SQSQ, and upon receiving a new one, it will fetch the related OSX collector output file from the S3 bucket. And you can see actually the output of the OSX collector is packaged in tar.gz file to save some space because it's lots of JSON, so we want to compress it as much as possible. So it will Amira will also extract first decompress the file and then extract the proper JSON file from the archive. And then it will execute all these different analysis filters on the OSX collector output file. And after all this process, it will send the results of the analysis, for instance, to another S3 bucket, so the malware analyst can fetch the results from the bucket and see whether the machine was infected, basically read the whole summary of the analysis process. Here are the examples of the analysis results that Amira produces. So, for instance, we'll see some domains and hashes that were found on the blacklist that we're curating. It will also give you an idea about information found by conducting the external threat intelligence APIs. And then it will also provide you suggestions. So basically, for the things that were found on the external threat intelligence APIs but are not listed on your blacklist, it will suggest you to add them to the blacklist. Amira doesn't require too much configuration to run. Basically, all you need to do is to figure out on your own this S3 event notifications thing. It is well documented on the AWS documentation, so it's not really something difficult. And then just to run it, you basically need to specify SQSQ name and the AWS region where the queue was configured to run. There is also a possibility to specify this results uploader. So there is, for instance, possibility to add also some other results uploader. So results uploader are basically a way for you to tell Amira what to do with the analysis results. So you may want to add some other way of distributing the results. For instance, you may think about sending the results of the analysis via email or some similar, or basically attach them to your incident response platform if you have some more advanced system to triage these alerts. And that's sort of why I was mentioning that kind of this S3 bucket, the end results of the S3 bucket is optional step. Are there any questions so far related to Amira?
Are you using it as a Lambda function, or are you running it as your own EC2 instance?
So the question is whether we are using it as a Lambda function or running it as our internal instance. So we are running it as our internal instance. Yeah, there are several factors. Lambda factors are really cool, but I found them quite tedious when it comes to importing some external dependencies, like basically this whole OSX collector output filters. But our first idea was actually to think about Lambda functions. There were some other questions. Okay, if not, let me continue. So actually, you can go even a step further with all this forensics and also automate the forensics collection step. So basically, what you can do is instead of just getting the machine and running the OSX collector script on the machine, you could think about basically having some scripts that will run OSX collector on the machine and, for instance, upload the results to an S3 bucket. If you have large installation in your company, so like we at Yellow have around 4,000 employees with macOS systems, you probably use something like your inventory management system. You could think of basically just dropping the script to run OSX collector collection and then uploading the results to S3 bucket, and that will trigger the Amira to run the collection, run the analysis on the results. Here is an example of such script. It's very basic. I actually stole it from someone else. It's the only thing it does. It's just calculating this signature for AWS S3, so it can send the file there and then trigger the whole analysis process. So the whole analysis sort of saved us a lot of time. In certain cases, it saved us up to like hours from several days. It used to be when we were involving also help desk into the whole collection process. We have to wait for them. They were in different time zones. Sometimes they had to chase the user, which was also in the other time zone. So the whole process could easily take up to several days. And then the whole analysis, as I mentioned, when it was interrupted, Amira takes basically all this effort from you. You don't have to sit there, watch how it collects all the information from various threat intelligence APIs. It also reuses lots of caching mechanisms. So all this OSX collector output filters, it comes packaged with some basic cache that will not issue the same queries. For instance, if the user visited the same websites, I mean, most of the users are actually visiting probably like 80–90% of the websites they're visiting are the same. So when we're running the process on by each individual malware analyst, basically all of them had to pretty much get the same information all over again. And with Amira, we're just able to have this information get once from the APIs and cache it. So, for instance, saves us lots of quota from the external APIs, and it basically makes the whole process even faster. It also cut all this interaction between the malware analyst and help desk. So right now, Amira is taking care of forensics collection, also the analysis. Obviously, there is a need for analysts to review the whole result summary and actually provide remediations that are then executed by the IT engineer help desk. But still, like, there is less sort of human interaction, less errors possibly that could come all over along the way. Also, there is no need for this physical collection, so even less problems with basically chasing users down the corridors and taking their machine off the network. We can just remotely run the script, collect all the forensics, get the analysis done, and then basically malware analysts can sit down and look at the analysis and figure out whether there are any false positives or weaver down any sort of other problems. And it also allowed us to do more proactive forensic collection. So right now, even on the machines that we are not really sure that they're infected or not, we haven't even received any alerts, but potentially there is some suspicious network activity from our DNS resolvers. We could proactively run a Mira and get all of the forensics, analyze them, and then figure out whether the machine is infected or not. And the whole thing is open sourced, so go try it out. I'm really looking forward for any questions related to the project, any issues that you've spotted. If you have any suggestions, also don't be shy, create some pull requests, send them my way. I'll try to review them. And on that note, I'll like to thank you for coming, and I'm open to take any questions.
What kind of false
False
positives
positive
do you get?
percentage? I'd say it's probably way more than 80%. Like around this like 80-20% rule, right? So I guess some of them will be clearly false positive. Some of them will be like, oh, it is a threat, but it's not applicable for this particular machine. And yeah, Amira basically helps us to figure this out, because even for certain threats that are, for instance, our endpoint monitoring, say, are Windows only, we'll still get the alert, and then we'll have to figure out, is it seriously Windows only? For instance, some browser extensions, they don't really are related to any systems, so that's how we can also analyze it.
Are you planning any integrations with like sandboxing technologies, Cuckoo or anything like that?
Yeah, so regarding sandboxing, so this is purely sort of for forensics collection, so there is no sample collection. Obviously, it would be very interesting to connect it also with something that could process a sample, but then we are sort of approaching this problem of how we are transferring the samples along the way. So for instance, Google Rapid Response Framework, they do something that allows you to pick a sample, and I guess at that point in time we would be able also to have some more reliable analysis when it comes to the file. So far we are operating basically on file hashes, I guess, file names, things like that. I mean, URLs are pretty okay. Like sometimes we are basically collecting a sample from the original URL rather than from the machine. Because also maybe sort of to give you a heads up on all this remediation process, apart from just getting rid of the threat on particular instance, what we are trying to do as well is block domains, block IP addresses serving malware. So at this point of time, actually, it is more important for us where this threat got from, and if we are able to pinpoint it to particular domain URL and get a sample there, then we know we have to block it, right? So it's actually more related to what we are doing later in the step.
So now that you're able to collect a lot more and analyze a lot more at scale, have you found particular things that you've particular indicators or particular types of data you've collected now that were not worth collecting before?
That were not worth collecting
weren't
before
worth collecting
in
before
terms
because they
of
were
data.
too expensive.
Yeah, so there are particular parts of forensics collection done by OSX Collector. It tries to get as much information as possible. That's why there's 30K lines for a machine that was running, I guess, for several months. And then the whole analysis process is also longer because of that. Yeah, we decided, for instance, not to look too much into cookies collected in the browser. There were several issues actually with that. Also that collecting cookies value from someone's machines is a security issue in the first place, because you're collecting lots of information that should not leave a machine, or there is assumption it's not leaving a machine. Sometimes we get some noise related to one of the filters. So there are filters that try to extract domains from particular URLs. There are also filters that try to create kind of a network graph of related files. So for instance, if you have some related files to the one that's infected, maybe it's potentially interesting to look at them as well. And these are most of the part too noisy to be actually taken seriously. We very seldom look at them.
On the latest Mac hacks that are out there using GPU graphics attacks, are you looking at those?
Not really. I'm not too familiar with them.
I was wondering if you keep your OSX collector files and periodically rerun them, as your threat feed updates, and if that's proven of any value to you.
Yeah, so far what we are doing, we are keeping the malware forensics that we collected from the machines. We are not, Amira yet is not too stateful. Apart from this cache that I've mentioned earlier, it's not creating any state. There was actually a project that was presented at ScienceCon in Utah last year where people were trying basically to also put all this information. I think it was MongoDB, but you may think of, okay, let's put it in something like Elasticsearch Cluster or Splunk, and let's query it. So these are potential next steps for this project, basically. Apart from just taking as like one machine individually, let's try to see how this machine differs from all the other machines in the network. This is actually something that OS Query is able to do, for instance, like having the whole fleet of machines and trying to compare one machine against all others in the same infrastructure.
What's the runtime of collection and Amir? I mean, how long does it take on each laptop, and how long does it take to process?
So the whole collection process, so just purely OSX collector script, it does rely on how, basically, for how long time the machine was used. If the machine was used for several years, you will, and for instance, like browser history is not purged, like you have lots of apps installed, it may take quite some time. Then the whole, so like worst case, like, up to a day, let's say. Yeah, we had the cases when it was like running for a day, like it was still in the good old days of help desk engineers trying to get the machine. Right now, as we are running it by our inventory management system, to be honest, we don't collect too much insight about when the collection was started and then when the collection was finished. We only know this time when the collection was finished. So you don't know if the collection took so long because user, for instance, was not in the office for like a day and his machine didn't beam up to the central inventory management system. In the best case, I had actually on my when I was preparing the presentation, I had a case when the whole collection and analysis process, so also running analysis, which can also may take up to another several hours. It took 8 minutes basically from collection to having the results available for the malware analyst to look at.
You mentioned started doing proactive collection. Have you looked at collecting that data and trending on the data over time in something like Elasticsearch or Kibana?
Yeah, so this is something we are not doing yet, but definitely something I'd like to work as a next steps, basically, after we automated all of this.
Kind of similar with respect to active defense. Do you guys have a particular threshold that you have to meet in order before you deploy the script, or do you just kind of have the script, already available to run on machines, and you run it across all your machines, or do you have to reach a threshold?
So yes, we do have something like a threshold. It's basically this alerts we get from endpoint monitoring or network monitoring. So this is our initial kind of trigger for the whole malware incident response process. But then we had some cases in the past when we were suspecting part of the fleet to be infected with something. And then with just one click, we were able to deploy the script to like hundreds of machines, get the analysis done by the next day, and look at this. So it's way more scalable than our previous approach in this matter.
What kind of file sizes does OSX Collector put out? Like, have you seen?
File size
Yeah,
in terms of the collection. Yeah, so not sure if it was actually on the slide, but the compressed TarGZ file, it's usually several megabytes. If you decompress it, it's like, I don't know, 60 megabytes, 80 megabytes, something like that.
Okay, any other questions? Still? Okay, then no, thank you, Kuba. Let's hear it for him.